Good afternoon, everyone. My name is Sam Schwartz. I'm just going to introduce Sustainable Business Solutions, which is sponsoring this particular webinar today. Sustainable Business Solutions is a fully integrated interdisciplinary firm based in the DC metropolitan region, offering building professionals, owners, and operators precise energy efficiency, wellness, and sustainable solutions for new and existing assets. Their ultimate goal is to provide full circle solutions addressing maintenance, reliability, durability, life cycle, and sustained energy performance. They've worked on over 142 million square feet of mixed-use projects covering all market segments. And their core competencies include building performance consulting, commissioning, air leakage inspections and testing, sustainable program management, trades training, measurement and verification, and other related services. So thank you very much to Sustainable Business Solutions. So today's webinar, we are going to talk about transforming a White House parking garage into an office space. And we're going to talk about integrated sustainability and energy performance. I'm going to start with a few housekeeping notes before we get started. The presenters will be holding questions throughout the presentation until the end, so we encourage you to submit them at any time, and we will revisit them at the end of the presentation. If you happen to be experiencing any technical issues, please use that chat function. You can message the panelists, and we will do our best to assist you. This presentation, if you're wondering, is being recorded and will be available for viewing within 1 week. And then finally, in terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. If you're a certified CXA or an EMP, your CEUs will be automatically uploaded to your respective portals. So today we are joined by Rachel Nicely, Jake Torok, and Charles Jackson. A little bit about each of them. Rachel is a director of sustainable programs at SBP. She has been in the sustainable consulting business for 14 years, serving the commercial and residential markets. Jake is a building performance manager and has been involved in the energy consulting business for over 12 years. He's responsible for developing and overseeing commercial and large residential projects related to building energy performance and sustainable design. Charles is a commissioning team manager for Sustainable Business Building Partners, like his two colleagues here, with more than 15 years of experience commissioning electrical power systems and mission-critical facilities. He's responsible for the commissioning team management and resource oversight, as well as project management of unique and complex project types. And fun fact, he also currently serves on the ACG Board of Directors and was named Consulting Specifying Engineers Magazine's Top 40 Under 40 for this year. So without further ado, I'm going to hand it off to the experts, and we're going to get into a little bit about this case study today. Charles?
Yeah, hi. Thank you so much for having the SBP team here today. This presentation is Transforming a White House Parking Garage, an integrated sustainability and energy performance case study. I think, Charles, we may be sharing the wrong screen.
So do you mind hitting the swap displays button at the top left? There we go.
Great. And if you could go on to the next slide. So our project is located on 22nd Street in Washington, D.C. It has over 90 years of history. It was first developed in the 1930s as a Cadillac car showroom. In fact, it operated for about 40 years as such until it was transformed into a parking garage for the White House, as you can see on the bottom right corner. In 2017, Berenstein Management Company had the vision to reuse the structure and transform it into a multi-tenant office building. And the next slide will give you a project overview. The building is just under 60,000 square feet and 5 stories. It achieved LEED Gold certification in the version 4 building design and construction core and shell rating system. The project team included Berenstein Management Company, Cushman Wakefield, Perkins and Will, Wiles Mensch, Capital Engineering Group, HIT Contracting. And then my firm SBP was contracted for sustainability consulting, energy modeling, and commissioning. So today our team's going to take you through SBP's scope on this project. I'm Rachel Nicely, Director of Sustainable Programs, led the consulting and lead administration. Jake Torok is the Building Performance Manager. He is lead on the energy modeling effort. And Charles Jackson is the commissioning team manager leading that effort as well. So on the next slide, I'll start by giving you the lead and sustainability overview. On the left, you'll see a performance summary, kind of shaped like a nutrition label. It outlines the project's performance in each of the LEED credit categories. The green on it acts as like a progress bar, showing the performance in each of these categories to visually represent in the areas of performance within the 110 points in the LEED rating system. As you can see, the project earned about 64 points, which is well over the gold threshold. The project demonstrated particular performance in location and transportation, sustainable sites, and material resources categories. So instead of taking you through all of the sustainability attributes and all of the points in the scorecard, I'm going to highlight 3 focus areas I think are the most impactful outside of the energy performance, which Jake and Charles will dive into later. So location, it's located in a priority designation as well as an urban infill promoting walkability and transit. An adaptive design, really highlighting the resiliency, and the green roof promotes for rainwater management and heat island impacts. And then embodied carbon, which I'll get into in a second. Yeah, go to the next. So this project is located in close proximity to DuPont Circle and DC's West End, and about 4 blocks from the Metro Center or Metro Station. It has a high walk score and bike score, which are very good indicators of the infrastructure in the area to support alternative means of transportation beyond the public transit opportunities. And then the project is also listed in the HUD platform as a difficult development area, which means that it's an area with a high land construction and utility cost relative to the area mean income, which is an indicator as well. So all of these aspects lead the project to perform well in the location and transportation category, and demonstrates that it supports a community and promotes alternative means of transit, which help reduce the occupant's carbon footprint. So now focusing on the area of adaptive design, I want to highlight the rooftop and how it provides significant benefits for rainwater management and heat island impact. The vegetated roof is designed to manage the rainwater on site, which is a priority for the DC zoning requirements. The combination of the vegetation and reflective roof paper mitigates the heat island effect, which is the absorption of heat radiating to the surrounding area. So these attributes provide significant benefits not only to the resiliency of the building asset and occupants, but to the surrounding community as well. And then the last of the focus areas I'm highlighting today is the embodied carbon reduction, but I'll start with some definitions. So operational carbon is what we as energy professionals are familiar with. The carbon emissions associated with the operational energy used for heating, cooling, equipment, and lighting. Embodied carbon is the emissions that come from the manufacture and transport of materials used to construct the building, the wood, the insulation, the steel, the facade, the concrete. And then the operational and the embodied carbon together give us a good picture of the whole life of the carbon emissions associated with that building. So on the next slide, for this area, focusing on embodied carbon, I'm highlighting the benefits of reducing the emissions associated with building materials and construction. As an adaptive reuse project, the structure of the parking garage was maintained, which offset the impact from the new building materials. So our team used one-click LCA software to evaluate the embodied carbon impact for against a new ground-up construction of a building of the same size and dimensions. So looking at the analysis on the screen, we formed a box model. The embodied carbon impact is represented in a heat map, highlighting the heavy hitter materials. So here you can see that the concrete slabs would have had a major contribution to the embodied carbon impact. This image provides a visual representation of the embodied carbon impact for offsetting brand new concrete slabs by reusing the parking structure. So on the next slide, a material life cycle assessment of the whole building was performed to evaluate the cradle to grave impacts from these two different scenarios. So we have the ground up construction, which is the baseline, against what the actual building design entailed. And then the life cycle assessment results were able to demonstrate a 48% reduction in embodied carbon emissions with the decision to reuse the structure, which contributes to the overall carbon impact. And on the next slide, you can see it gives us an opportunity to look at the total carbon of the whole life cycle of the building through operational and embodied carbon. So the total impact for this project, we can see that it equates to about 34,000 trees planted, or about 454 cars per year off of the road. So with that, I'm going to close the sustainability focus areas I wanted to share with you and turn it over to my colleague. Jake Torok will take you through his team's building performance analysis.
Great, thanks, Rachel. Yeah, again, I'm Jake Torok. I'm a manager with our building performance team, and I was directly involved in the day-to-day on this project, staying on board through most of the design process. So I'm going to walk you through what our role was as part of that design team, talk through some of the project's goals, the challenges, and eventually talk about where we ended up. And we picked this as a case study because we had some really good lessons learned, some really good takeaways from this project workflow that I think translate really well to a lot of the other projects that share similar goals, kind of that pursuit of high performance, pursuit of sustainability. All right, next slide. All right, so my team was fully integrated within the design team. So we worked directly with the architects, we worked directly with the MEP engineers, the ownership group, to help inform and help optimize this design. But at the center of a lot of our involvement was whole building energy modeling. And I'll go into a little bit more detail on the next slide here, but the big understanding or point of understanding with energy modeling is the value is that it allows us to quantify. We can put a number to some of these big design decisions that we're making early in the design process. So that ability, coupled with a traditional method of evaluation, which is a bit more qualitative, gives you a really good, full, holistic understanding of some of these design decisions you're making early on. So in addition to that design optimization scope, we're also able to adapt that energy model and use it for more benchmarking. So first would be energy code compliance, where traditional energy code compliance, which fits within our building permitting process, is more of a prescriptive method, where you go down a checklist of design features and you check each item as you design it into your building. Doesn't matter how valuable or how much it impacts your building, you have to meet that. On the other side of the energy code world, and this is less known, is a performance-based metric, where we can use that energy model to put a number or make a prediction based on operational energy performance. So we're looking in terms of energy or energy cost as opposed to specific design features. So assuming your total energy is less than whatever your baseline, your budget is, you're considered a compliant design. So what that does is gives your team a lot more design flexibility. So you can piece together a design that's customized for your building, and that's okay as long as your overall performance is compliant. So we promote this for a lot of our high performance buildings pursuing LEED or beyond LEED certifications, because you can really customize it. You can get the best value out of some of these design decisions. On the other side to that, kind of the parallel effort to this is we can further adapt that energy model and apply it to LEED benchmarking. So part of the LEED benchmarking is the energy and atmosphere credits, and the primary credit in there is dependent on energy cost savings. So that modeling tool is built perfectly for that type of metric, quantifying energy performance versus some standardized or arbitrary baseline. So we further adapted it. We applied it to the LEED benchmarking project to support with those efforts that Rachel kind of covered in the previous slides. All right, next slide. So a little bit more about energy modeling. I'm not sure what the group's understanding here is, so I'll give a quick rundown. So the best way to describe whole building energy modeling is it's basically a digital representation of your building, which is a slight oversimplification, but I think it gives you a good visual of what goes into this. And I call it an oversimplification because really it's harnessing your full design, but it's taking it a step further. So we're importing anything that impacts energy. So something intuitive like lighting, very straightforward. But we're also looking at things that are indirectly influencing energy. So your wall assemblies, your roof assemblies, and what particularly goes into those assemblies. So your materials come into play here and how that impacts heat transfer. So we're accounting for all of this. But our goal here is energy or energy consumption being our output. So we have to fill in those gaps between design and energy. So that's where schedules come into play. We make predictions based on how these loads, how the lighting is going to behave, how people are going to use the space, HVAC set points, and we apply schedules, predicted schedules based on typical operation. So we apply those to our loads. And then that last missing piece before we can get to that output is weather. So we input a weather file into all of this so that our software now can take our loads, our schedules, and our weather conditions and make predictions based on what this building is going to do. The simplest output is energy. We can look at annual energy consumption, but that's just the start of what data we have access to. So really, we can break that data down to hourly or sub-hourly data if we really wanted to. We could run our software at 1 minute increments and have a data point for every one of those. And it really goes well beyond energy. Energy is just the simplest understanding of an output. We can look at demand, we can look at loads, we can look at temperatures within an air handling unit, we can look at flow rates, you name it, we probably have access to a data point that can tell a story about that building. So really, we have access to an unlimited, nearly unlimited amount of data about these buildings, and we can apply it, we can adapt and interpret it based on whatever our project's goals may be. So that's kind of the overview of how it's used in the design world. Then there's a whole post-occupancy application of energy modeling as well, which we did not apply to this project. That's kind of one of those things looking back. We wish we probably had pushed that a little bit more, but there's a whole calibration, post-occupancy benchmarking that you can use modeling for, where you're creating this great design tool, but then once design ends, a lot of times we're just leaving it and never touching it again. But we can come back post-occupancy. That can serve as a benchmark now, a point of comparison to use for diagnostics, to use for M&V exercises, a lot of possibilities in the post-occupancy world, which we're seeing a lot of on newer projects now. So I think that's kind of the next big application for energy modeling and really energy consulting in general. But we'll leave it there. Next slide. All right, so Rachel kind of gave us a really good overview of this project. And as we're working with the design team here, there were a few goals that were really clear to us and that we knew we had to design around. Some of these are ownership driven, some of these are funding driven, and others are just required by the jurisdiction. But LEED certification, as Rachel covered, was a primary goal for this project. Energy code compliance is obviously one of those jurisdictional requirements, no permit, no building. And 3 here, future energy or future performance is an interesting one. So any owner cares about operational performance. I mean, utility costs are a big deal when you move into the operational world here. But there's something else interesting in DC that becomes a motivating factor, particularly on the design side, in that DC has what's called the Building Energy Performance Standard, or BEPS is what we call it. And traditionally, jurisdictions regulate design and they regulate construction. But what jurisdictions, and DC included here, are now doing is they're regulating operational performance. And what DC did within their BEPS program was established a median building, almost like an average building. And if you're in the bottom half of operations compared to that median, you now are required by law to improve your building. Failure to do that results in a hefty financial penalty, something on the order of $10 per gross square foot for non-compliance. That's significant, and significant enough that it makes us think a little more at design phase about how these buildings are going to behave in the future. So really, it comes down to future-proofing these buildings and making sure we're designing them such that they can accommodate some of those requirements in the future. Even if it's 5-10 years down the road, we need to make sure we're doing what we need to do at design phase. So that was all part of this conversation, and absolutely part of one of the main goals going through this process. So we've alluded to kind of some challenges, and I think some of these are very intuitive given the fact that it's an existing building and it's a speculative building. But we'll run through what these challenges are, and then we'll talk through kind of how we overcame some of these. One, zoning limitations, and Rachel alluded to a few of these, but being an existing building, in this particular situation, we couldn't build up. So we couldn't add floors, which gives you a little more design flexibility, gives you a little bit more ability to overcome some other challenges here. So we were kind of set with the structure that we had, which is fine, but definitely a limiting factor here. Second, it's an old building, but it never received a historic exemption. And why that matters is really in the energy code and LEED benchmarking world, where generally there's a little bit more leniency. If you have a historic designation, you can overcome some of those code requirements that might be a hindrance outside of that, but didn't have anything like that to lean on. Moving into the site and structure, like any existing building, you're stuck with the structure you have. And fortunately, this was a structurally sound building, but we couldn't really modify too much because, again, you're governed by what you have. You have electric structure and limitations here, the service coming into the building. Again, not much of an issue here, but definitely something that was acknowledged as part of this design process. But what's really unique to this building, and Rachel showed an image earlier that showed the same thing here, but because it's an existing structure, because we're kind of stuck in the middle of this high density area, we have issues with shading on this roof. And I have two images on this slide. Lower right is just the front facade of the building, kind of that central building being 1222, south being to the left of that image. There's a large building right to the south. The result of that is that upper right-hand image where south is down, this red circle right in the middle is kind of highlighting what I'm showing here, and that's the shading. So this, just based on where the shade is probably somewhere in midday, but I can tell you throughout most of the day, throughout most of the year, there's some shading on that roof. So one of our goals is a high performance building here, right? The first thing you naturally think about is solar. This is clearly not a great application for solar. And we do advocate for solar in the district. It is cost effective. It makes sense for most projects, but for something like this, it's probably not a good value because you're going to be losing a lot of the output of that system. So not something we pushed here, but definitely something we're keeping in the back of our mind for a potential future application. And lastly here, I alluded to this one already, but this was a speculative building. So with any speculative building, you're designing for a potentially unknown tenant. So as an owner, you have to make sure your building is flexible enough to accommodate any kind of future tenant. You don't want to restrict yourself too much with lease language or any other kind of restrictions that might push a potential tenant away. So you have that tenant flexibility, but what that does is puts more risk on the owner. That puts a lot of the onus on the tenant to ensure you have good operational performance. And I'll get a little bit more into this on the next slide when we talk about the design. So I'm going to work backwards on the next two slides here. I'm going to show you the end result, and I'll talk about how we got to this end result. So I'll be the first to say, I mean, this is not the highest performing building I've ever seen. And we had a lot of challenges to overcome. And I think we ended up with a really good design, given those challenges and given the project's goals. So on the HVAC side, we did an evaluation early in design, looking at a couple different system configurations. We weighted energy performance versus some of the other benefits of these systems. And the team ended up settling in on a water-cooled VAV self-contained unit. So this is good for a few reasons. One, it's limited roof area, and that was a really big deal here because you've seen a couple images of that roof area. There's a lot of competing interests up there. So having a limited roof footprint is extremely valuable here. The other valuable part is the tenant flexibility. This has zone level fan power boxes, which for a tenant fit out is easy to adapt, easy to customize when you're given kind of an existing central air handling unit. So it accommodated tenants really easily. We also looked at some VRF applications here and a few other kind of variations of those system configurations, but ultimately settled in on this one. And the other part about this we like is it's not your code minimum system. They ended up going with a really good selection here that has really good part load performance. So we see that value in normal everyday operation, water side economizers, good system level controls, but this also gives tenants some flexibility on controls as well, having those tenant level boxes that they fully control, they're able to install and tie in associated sensors and monitors with them. On the lighting side, the owner only controls a small portion of the lighting, but it's still a bullet point here. It's something that really matters if you're really pushing these buildings to the next level. So lobbies, stairwell, circulation, back of house lighting was a point of focus on here, going with a predominantly LED design, putting in advanced controls beyond what just the code requires. And we're seeing that in the form of a 35% reduction in energy, which is significant. Third here, we've talked about this a little bit here, but it was a poor application for on-site solar. So the ownership group looked at the off-site alternative. And this is not a marketing rec purchase. I'll be very clear about that. This is a tier 2 rec purchase. And tier 2, if you're not familiar with that, basically means that is directly subsidizing new off-site solar installations. So this is not purchasing from some residential home in the district or somewhere outside of the district. This is actually working to directly improve our regional grid. So this is a valuable rec purchase, and it's not a small amount. A 50% offset for a long-term contract has a lot of value in our region. And fourth here, I list this fourth, high performance tenant fit outs, but this is probably the most important one of all of these. So I mentioned before that this group, and we ended up giving the tenants a lot of flexibility here to do what they can. And this building was very fortunate in that the primary tenants coming in had their own sustainability goals, had their own high performance energy performance goals. That helps because tenants are going to directly control about 40% of your building energy, give or take. So that's tenant lighting, plug loads, IT equipment accounts for about 40% of the energy that the owner has little to no influence on. So as an owner, even if you design a great building, you're only controlling about 60% of your energy. That tenant also is going to influence a lot of the remaining energy. So they dictate HVAC operation. They dictate, in some cases, set points and how long these systems are running. So the tenant has a lot of influence on these buildings. So securing another high performance tenant that shares your performance goals really pays dividends in terms of operational performance. All right, next slide. So kind of continuing to work backwards here, we're going to walk you through how we got to that end result, talk through some of the process. And context here is the reason we picked this case study is less about the design and more about the design process. This was a great design process because we had some clear challenges we had to overcome, but then we had owners that were receptive and open-minded. And likewise for the design team, they were very receptive to feedback and everyone understood the project's goals here. So that's the big takeaway from this is that it was a really effective, fully optimized process to get to that final design product here. So my group, my building performance team, we came on board fairly early. We generally like to come on board of projects at concept at the latest. So we have the most influence on design. We came on board a little later on this particular project, but early enough that we still had a voice. We still had some influence on this design to help guide the team. So we started the energy modeling process really early. As soon as we got on board, we started building that energy model because there were some major design decisions we were trying to make, HVAC being one of them. We built the model, we put numbers to a lot of these design decisions, and then we had a meeting with the team. We pulled in the architect, we pulled in the MEP engineers, we pulled in the owner group, and we started having a conversation about some of these decisions, about some of these metrics that we're pulling out of the energy model. And we asked that team at that point, okay, what are our goals? Let's prioritize what our goals are here. So where are we going? Then we follow that up with recommendations and suggestions on what direction we should go. And that's the how do we get there? And the takeaway here is this is not us sitting and preaching. This is not the owner sitting and preaching requirements. This is us making recommendations, us providing data to help make an informed decision. So in the end, it becomes a discussion of what's feasible for this project. And once we get some conclusion on that, the design team goes back to the drawing board. They implement these recommendations, and then we revisit this about mid-design is what we call it, somewhere mid-DD, early CD in that range. And we make sure, okay, are we on track? So step one is about putting us in the right direction towards our goals. Step two is making sure we're on track and we're going to hit some of these targets. So we revisit that energy model. We update it based on some of these changes. And then we work to one, further optimize it. If we're short of our target or we pushed our targets a little bit, we can re-optimize. And then second, this is where we start benchmarking. So we don't like benchmarking too early in design. Benchmarking being we're comparing against some baseline. So this is where energy code comes in. This was where lead benchmarking comes in. We start the conversation now, and it's more of a check. Let's make sure, hey, we're on track for code. We're on track for some of our lead performance targets. So they're not really informing our design. They're more of a, let's check in, make sure we're good here. But the crux here is that we're really pushing to the design optimization. So once we've settled that, we move into later design. So this starts about permit is how we classify this. And this is less about optimization, more about fine tuning. So at this point, we should be on track, and we were on track for our targets. We have kind of worked through all of those challenges during that early and mid design phase. We are on track. So now we talked about, okay, is there anything else we can do? We can look at some more intricate controls. We can talk about future proofing. What design strategies didn't we implement that we could position for sometime in the future when BEPS eventually comes into the picture? So things like metering, things like additional electric infrastructure, things like that. We had those conversations. Not everything got implemented, but that's kind of where this comes in. Then by this point, we really had high certainty of where we were. We knew where we were in code. We knew where we were for lead benchmarking. No red flags, nothing caught us by surprise. So as long as you're working throughout the entire design process to optimize and make this design the best that it can be, those last two bullet points become kind of checkbox items. Because modeling for code, if you've done everything you're supposed to up to that point, that should just be a documentation exercise. You know you're compliant with high confidence. And then the lead benchmarking. If you're optimizing this design, you should do extremely well on lead. We don't always recommend designing for lead or designing for code compliance, because that can distract from what kind of really matters in a lot of these buildings. But I'll be the first to admit there definitely is some synergy and some kind of overlap with some of the lead requirements and code requirements coming back to inform our design. But really, the goal here is just optimize, push that design, and everything else should kind of fall into place at the end. And that's exactly what happened on this project. We had those early discussions, made everything later in the process much easier. All right, next slide. So not every project is perfect, right? I mean, there's a lot of things we wish we could have done on this project given this different circumstances, and for whatever reason, not all of this got implemented here. But I think to provide the big picture and a good holistic understanding of this process, I think it's fair to kind of point out what some of these other things we could have done are, just to kind of help inform the audience and what this process could have been. Number one, I've alluded to this a couple times here, but this is life cycle involvement or cradle to grave impact on this project. So I mentioned we like to come into these projects early. The earlier you get involved, the earlier you have these conversations, whether we're involved or not, the more influence you can have on design. It's a lot easier to change programming, change structure when you're at concept or pre-concept than it is when you're just about to start building this thing. So getting involved early. Then on the other side of that is this post-occupancy world that I alluded to at the very beginning. And I'm assuming that's where a lot of the audience sits, is that side of the industry here, where we can continue to optimize, we can continue to push these buildings even post-occupancy. Having a tool like energy modeling just provides an extra tool in our belt to help do that and help push those buildings. Electrification is kind of that term we're seeing everywhere right now. And we have a kind of a subterm for that we call strategic electrification or smart electrification. We've talked about electrification on this project. It is a primarily all electric design. All the primary systems are 100% electric here, but there's a next level conversation. And that's about smart electrification and whether what we're doing is really best for the building and best for future-proofing this building. And I won't get into too much detail there, but definitely a conversation we're having on a lot of newer projects. And then along the same lines is the idea of solar ready, where technology or solar technology right now may not do well against shading, but maybe a technology in the future will. So putting in a plug and play infrastructure that supports solar could have been something we considered on this project. And lastly here, we had conversations about tenants, we had conversations about tenant flexibility, but again, there's just like the electrification, there's this next level conversation we can have on projects now, and we need to start having on projects. And that's how much do we limit tenants? How much control do we give tenants? The fact that they influence so much of our building energy and directly control that 40% chunk of our energy. Do we start talking about lease restrictions, limiting lighting, limiting IT equipment in these spaces? And that's a big risk for landlords, but gives us more peace of mind and confidence in future operational performance. And then the more subtle side of that is simply just educating tenants. Is there more we could have done to educate these tenants coming into the building? All right, next slide. All right, and just to close this out and bring a lot of this together here, just a few key takeaways from this process. One, holistic design strategies lead to better performing buildings. So this is not Jake sitting here preaching to a design team. This is having a discussion amongst all the design team entities, figuring out what works best for this particular building and starting those conversations as early as possible. Number two, designs must consider long-term implications. I mean, traditionally, we've designed for code, we've designed for LEED, and then we stop looking at these buildings. But now we need to think long-term with things like the BEPS law in DC, which similar programs are popping up in a lot of other jurisdictions here. So we have to think about operational performance, operational carbon. Three, tenant buy-in is imperative. And we've talked about this. They just control so much of that building. If their goals are not in line with building owner goals, we're not going to get the result we want. And lastly, this is nothing I mentioned explicitly on any slide, but if you take something away from this, it's probably this bullet point here. Data equals informed decision-making. So this means the more you understand about your building, the better decisions you can make about your building. So this is true in design. We have the energy modeling tool, which gives us data, right? There's a lot of other ways we can do the same thing in design, but the more we understand, the better our decisions are going to be. This works in the post-occupancy world with metering and monitoring and just having access to data about our buildings. And this also works in Charles's world, in the commissioning world, where understanding how these systems are running. So I think that's a good segue over to Charles Jackson, who's going to talk about the commissioning process on this building.
Thanks, Jake. Hopefully I can keep everybody entertained as all the cool stuff that you're learning on the energy side. So let me go to the next slide. There you go. So the commissioning scope here, as Rachel mentioned at the beginning, we're doing LEED and it went LEED Gold, but it was version 4, fundamental enhanced, which one of the cool things about version 4 was that was the first inclusion on the LEED portion for the electrical commissioning as well. So we looked at our scope, HVAC, electrical, and plumbing. Within there, we're there from the beginning. So we incorporated design review, submittal reviews as well, site visits, functional testing, training, and the warranty visits. So that's kind of the overall commissioning scope. But as we deep dive, we had your HVAC system. So as Jake mentioned, we had our self-contained AC units. We had the cooling tower. We had VAV boxes, fans, heaters. So things of that nature. And one of the biggest challenges, and we'll get a little bit more in that, is when you're testing a core and shell building, that there's a lot of open space because the tenant portion hasn't come in, and this is the same with the HVAC. So you'll get a preliminary tab, but a lot of times it's basically blowing air into open space where, yes, we'll meet the initial tab and focus on what we get from the AC units, but a lot of times you'll get more complete as you get into the fit house. So those are some of the challenges when you're looking at the HVAC system. Electrically, we had your panel boards, we had your switchboards, and of course the lighting controls, where I believe we mentioned earlier, we were able to get about a 35% savings, from the design. And I think that goes hand in hand as we go through some of the electrical testing, is making sure that the control system is working, the panel boards, verifying the breakers and verifying, the naming convention is all together. So I think those are the type of things we try to look for when you're looking at the electrical system. And then of course we have your the plumbing system, where you have your domestic hot water, which is something that we try to pay a lot of attention to. And then you'll have your recirculation pumps. So, and these are just a couple pictures of like on site during site visits and kind of the progress as we went through the project. So, and then we get to the testing portion. So this is after the construction is is complete, all the pre-functional checklists are ready, then we're ready to conduct our functional performance test and kind of go through that portion. So like I mentioned before, domestic hot water, this is just a sample of one of our functional tests that we provided, for this project. And kind of just simple, we kind of went through, you look at the equipment, water heater, expansion tanks, verified stall, you check the sequences, and you kind of go through and you check out the set points of the water at the different devices. So that's kind of our domestic hot water, which pretty much stands still, whether corn shell or you're even in your fit out. So these processes are pretty much the same. Lighting controls, as we said, we kind of went through and you check the different sequences, at the different wall switches, the photocells, your occupancy sensors, your time clock. So this is a actual test, that we actually ran through different rooms in the zones. We checked them out. I believe we had a sampling percentage on this one, and kind of went through, and then any issues that we found, we were able to close out prior to giving out the final report. And then, as we mentioned, you had your SCU. So this is just a sample procedure here that we had, and some of the challenges that you go through is as far as the heating and the cooling areas, as far as the windows, I guess the shading, that plays a importance when you get into the actual spaces. So a lot of, so that actually becomes a bigger deal when you're looking at some of the SCUs and some of the heating and the cooling issues. So that was the overall kind of big testing portion, but where are we now? So fortunately enough, we were able to look at the fit outs. So we were able to do the corn shell. So you have kind of the baseline of how the overall building's supposed to be. But now we're actually going back and testing some of the fit outs. So as the tenants come in, we're going through and kind of that missing piece in that final connection. And we're able to also utilize CX software because we were able to test a lot of the systems, from the corn shell. We have kind of a baseline data. We have those tab ports, we have all that data, and putting them in the software, we can compare as we go through the tests to see, how these results look now when we're in the fit out from what we got at the SCU. So I think these are kind of the things that we're pushing further. And as Jake mentioned earlier, it's all about, setting the building up for occupancy. So as we're testing, we're keeping those goals in mind. So that's kind of the next steps that we look through for this building to continue as far as the commissioning process and to help transition into operations. And I think that's our presentation. Do you have, now we're opening up for questions.
Thanks, Charles.
No problem.
So all of you online, if you have questions, now it's time to submit them. There's a Q&A button at the lower portion of your screen. Please use that. So let's get started here with some of these. The first question is, what do you see as the most important lesson learned from this overall process?
I can field that one first. I think comes back to a few of the points I presented here. I think this concept of holistic design, I think it's probably an overused term, but I think it's overused for a good reason, and that getting everyone on board in these early discussions, I think addresses a lot of these problems we're seeing later in the process. So things that show up in Charles's commissioning activities, stuff that shows up post-occupancy. Just having everyone figure it out early, implement the strategies to mitigate those, I think solves a lot of those problems.
And Jake, just one thing to add is having that future-proof looking, not just future codes, but looking for the operation. So making sure what we do in our design, taking into consideration how it affects operations, I think helps us go a long way further forward.
Okay, thank you. The next question that we have coming in is, do your 3 individual teams generally work independently, or is there a collaboration throughout the entire process?
filled that one. We absolutely have some collaboration. It's nice having these three services under kind of one umbrella. I particularly, my group works a lot with Rachel's team. Rachel is facilitating the certifications, a lot of those programs, and we're a lot of times kind of supporting some of those activities. But having that open line of communication, absolutely. Usually when I dip out of the process is when Charles is coming into the process. So I don't have as much overlap with the commissioning team, but I'll defer to those two for more.
Yeah, these two are invaluable to have on my team, as Jake is heavily influencing the design and how the scorecard shapes up. We're in close contact and helping them as well facilitate some conversations around, the importance behind building performance and code strategies. And then as we move into shift towards the actual construction of the building, Charles' team and their coordination on what's going on site, what do we see, how do we verify that the energy systems are being constructed as intended, is just incredibly valuable for our process.
Thank you. Before I get to this next question, I have a question just as someone that lives in DC. Do you feel like your projects are a little bit more complicated when you have it in DC versus Virginia, because there's a lot more sustainability goals or perhaps like building performance laws that you have to abide by?
So I guess from a commissioning standpoint and just overall, I actually enjoy the fact that we have stricter laws because it kind of holds everyone accountable. So I think in other jurisdictions where even though it's written down, if there's not being enforced, then a lot of times it's not required. So I think being in the DC area, especially within DC, these stricter laws help kind of, one, generate better buildings, but also holds kind of everybody to, this is what we have to do. So now let's look at how we can improve.
Okay, that's an interesting take.
Yeah, I agree with everything Charles said, and I'll expand on that even more because in the design world, it is absolutely a lot harder to design in DC because of everything Charles described, like having a more stringent code set, having a building performance standard to think about sometime in the future here. It absolutely creates some design challenges, and more so because we're still in the infancy of this, especially with the BEPS program, where it's a learning curve for a lot of these teams that they're adapting, they're pushing back, because they don't fully understand what these requirements are. But again, as Charles said, we're getting really good buildings as a result of this process. So it's a challenge, but it's absolutely worth it.
Okay, so there's another question here. I know you talked about a lot of variables for effective design, but someone was wondering, what is the single most impactful strategy that you found to pursue and create an effective design?
Goal setting, I think, is probably the best one I can think of. Whatever those goals may be, establishing them early as part of that like early concept, early design phase, setting them, agreeing on them, and making sure everyone understands them. I think that's definitely the single most effective strategy.
And then maybe just to piggyback and build on to that is communication of the goals and continuing to reiterate that these are the goals and how we're all on the page during each iteration of the design and construction, really, to communication.
Okay, so we have one more question I'd like to ask before we wrap up today. So the question is, how can you get building owners and developers on board with the idea of the sustainability and high performance measures for their buildings? But I was also curious if it's a little bit more of a stretch when, let's say, you're not in DC where this is not required. Is it more of an uphill battle?
Yeah, that's the $1 million questions, getting owners on board, and something we struggle with all the time throughout the entire process, from pre-design all the way through what Charles does. It's a really hard thing. it's still about money. Unfortunately, it's a financial game, and making an economic case for a lot of this doesn't solve the problem, but certainly helps. And fortunately, with things like solar, which has become economically viable in the last few years here, it's a much easier sell than it used to be. But beyond that, stringent codes help. They have to do it, so it makes the sell a little bit easier here. But certainly easier in DC, again, because of those mandates. Getting outside the district, it absolutely is harder. But I'll see if Rachel and Charles can jump in here.
What I know, one thing from my standpoint, what I've seen a lot of times is adding all of the costs. So you know, like, you have the cost of doing stuff, but there's also the cost of doing nothing, and that a lot of times is seen on that operational side of not, you know, being able to, you know, create more efficient buildings, use more efficient, you know, equipment that requires less maintenance. That has direct. So overall, it might not be seen on the construction side, but when you're looking at the life cycle of the building, then you take those into consideration, and it becomes a little easier to sell, making those changes now versus having to make those changes later on.
Yeah, I would agree with that.
I like that. The cost of doing nothing.
And tenant pressure is actually one thing I would add to that. The concept of tenants pushing these owners to do more is really helping design these buildings, especially if they're able to secure a tenant early on that has mandates. I mean, we've had buildings redesigned post-permitting because of pressure from tenants to do more. So that factor can't be undersold.
Okay. So we did have, actually, I think that we covered all of the questions. There's a few others here, but I think that we covered them in discussion. So Charles, Jake, and Rachel, thank you so much for coming on and giving us your time today to talk about this project. And thank you to your company, Sustainable Building Partners, for sponsoring today. I just want to give a shout out to our upcoming training from EMA. Charles, if you don't mind advancing this slide.
There we go.
So there is a special training that we usually don't produce, but we are producing it with AESP, the Association for Energy Service Professionals. EMA members do get that AESP 195 rate. If you go to our website, there's a promo code. It's just EMA, all caps, so you can take advantage of that. We don't know if we're going to have this training in the future, so if you're interested, it's only 2 hours, so I would suggest that you take a look at it. And we hope to see you at the next EMA webinar. Thank you, everyone, and have a great afternoon.
Thank you. Thanks for having us.
Thanks
Thank you.
all.